Hello and welcome to another video with Miss Warangel. Okay, so this is over data display and statistics, and I'm pulling these questions straight from your assignment that you'll be scheduled to take tomorrow. So let's go ahead and look at this first question. It says determining if a sample is biased. So bias means that it's leaning towards more of a certain group. So the question here, it says to choose a mascot for a new middle school, eighth grade students were polled, and their top choices was selected as the mascot. Was the sample a biased sample? So let's look at it, and we need to talk about what is a sample. So a sample is a group that is selected to represent an entire population. Okay. And then remember, bias is just leaning towards one specific group. So here, they are only asking eighth grade students. They're not asking any other grade. Well, does eighth grade represent an entire middle school? No. So this is actually a biased sample because it's only leaning towards eighth graders. Okay, let's look at this next question. The next question, it says, if no additional information was given, which display type would not show the number of observations? So when they're talking about observations, they're talking about how many times are you asking people a survey or things like that. Well, you can see in a bar graph how many people were asked, but you cannot see it in a box plot. So box plot is the only graph that you've learned about that it doesn't show you the number of observations. Okay, let's look at this next one. It says the histogram shows the results of a survey asking students how many video games they currently own. How many observations were used to create the display? So how many people were asked? So let's look at our histogram from 0 to 9. We have 4. 10 to 19, we have 9. 20 to 29, we have 10. From 30 to 39, we have 3. And from 40 to 49, we have 1. So to figure out the total, what operation would we have to do? Good, we would have to add them all up. Okay, so go ahead and add them all up, and I will wait to see what you get. Okay, so you should have added that all together, and I got 27, and I'll go back and double check it. So 10 plus 9 is 19, 20, 21, 22, 23, 24, 25, 26, 27. Okay, so 27 people were observed. Okay, this next one, it says, which plot has the greatest number of observations? So this goes with that same question from before. But now instead of looking at histograms, we are looking at a dot plot or also a line plot. Okay, so to figure out this problem, you literally have to count out all of the dots for each graph. So I'll go ahead and do the last one for you. So you have 2, 4, 6, 8, 10. Okay, and so what I want you to do is pause the video and figure out how many were observed in this graph and in this graph and see if you can figure out your answer. Okay, so what I have discovered is that this one has 11, 9, and then back to this one we had 10 here. So the answer for this would be the first one. What is the greatest number of observations? So for the first graph, 11 people were polled. Okay, this next one, it says 3 runners recorded their times for the 40-yard dash over the period of a year. Okay, so we need to think about runners. When someone is running, do you think that if they run for a really long time, so say you have your mile run, we have one person that runs for 10 minutes, that finishes it in 10, and another person that finishes it in 8. Okay, So the person who runs it in 8 minutes is actually having a faster time. Okay, so we need to think about that for the runners. It says use a table to complete the statements. So we need to figure out who is the fastest runner. So we're going to look at the mean, because they're in the mean, that's the average. This is the average time that these people are running. So the fastest time would actually be the smallest number. So Elena or Alana would have the fastest time because she has the lowest mean, the smallest mean. Okay. Then the most consistent runner. So the most consistent runner, consistent means that this person can do it at the same time, mostly every single time this person runs. So we need to think about what is range. Okay, range is that difference between it's from the smallest to the largest. Well, if this person has a very large range, like Alana or Elena, that means it's a variety. She doesn't run the exact same time every time. So maybe 6.2 seconds was the best time that she's ever had. Okay. So right here, 0.2, this is the smallest interquartile range. So that means Lorena has the most consistent runner. She is the most consistent runner because she has the lowest interquartile range. Okay, and we have a couple more questions. Okay, it says the dot plot shows the ages of players on 2 soccer teams. Which statements are true? Check all that apply. So let's look at the first one. It says the Lions have more variability in the ages of their players. So remember, variability is just range. Okay, so Eagles, or actually Lions, it has a player who is the youngest is 9 years old and the oldest is 12. And we want to find the range. So what operation do you use to find the range? Great, you would subtract. So 12 minus 9 is 3. So we have 3 here. If I were to look at the Eagles, their youngest player is 7 and their oldest is 12. Okay, and when we subtract that, what would we get? Perfect, we would get 5. Okay, so the Eagles actually have a greater variability or more variability. So this would be here. Okay, and then we can look at the Lions have more players. So how can we figure out how many players the Lions team has? Great, you would count the dots. Okay, so you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So we have 13 players here. And so since it has that word more, we're comparing. So we also want to figure out how many players does the Eagles team have? So let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and 14. So we have 14 players for the Eagles. So that means the Eagles have more players. Okay. All right, this last question. Okay, it says the mean of the ages of lions is less than the mean of the ages of eagles. Okay, so what I can do is the mean is the average. Mostly, this is where the age of the team is. Well, if I look at it, a lot of the players on the Lions teams are older than the players on the Eagles team. Okay, so that makes it true. Okay, all right. This next one we're gonna look at a dot plot. Okay, so it says for each statement, select the answer that correctly compares the 2 plots. So a typical 8 to 12-year-old. So we're looking at the 8 to 12-year-old box plot here. Blank times per day. So since we want to figure out the center, we're going to measure center. We can't find mean on a box plot. You just can't do that. So the next way to measure center is the median. So remember this line right here is the median. So that's about 62. So the average 8 to 12-year-old texts about 62 times per day. Okay? And then a typical 13 to 17-year-old texts blank a typical 8 to 12 years old. So they actually text more than a typical 8 to 12-year-old. Because if I were to look at it, this center is in between 75 and 80, and that is greater than 62. Okay? All right, and we have about 3 more. So 4 students conducted the same science fair project to determine the battery life of a specific brand of batteries. Which student's data would be most representative of the brand's battery life? So since we're talking about a sample, the greater the sample, the better the representation is. So Justin here tested 18 batteries. So since Justin tested more batteries, that is a better representation of a brand's battery life. So Justin would be the answer there because he tested more batteries. Okay, and the last question on your assignment, it says which data collections show bias. So remember, bias, it's skewed, it's towards one specific group. Okay, so we got to check all that apply. So 10 numbered tickets were selected from a bowl containing all raffle tickets sold. Okay, that's not bias. The next one, it says a bank asks its 25 wealthiest customers to complete a satisfaction survey. Well, at a bank, is it only the wealthy customers that are at a bank? No. You have different, you have wealthiest, you have average, and so on. So this is considered bias. It's skewed more towards wealthier customers. Okay, the next one, it says fifth graders were asked what desserts should be served with school lunches. Well, this is a bias sample because it's not just fifth graders who are in that school. Okay, the next one, it says every 10th semi trailer was pulled over and weighed at the state border. Well, that's not biased because it's just random. Every 10th semi trailer. Okay, the last one, it says college students at the Honors Library were asked who they voted for in the last election. Well, um, students who are in the Honors Library are usually like the top of the class. So this is considered biased. Okay, and the last slide. So these are key concepts to remember for your quiz tomorrow. So remember, a sample is a representation part of the population. You're trying to represent an entire population. Okay, sample collected with bias or sample sizes that are too small have skewed data points and graphical displays. Okay, the next one, it says data displays can be used to find the number of observations except box plots. And I added that there because in a box plot, you can't figure out how many people were surveyed. And the last one, you can compare data sets by looking at their measure of center, using their median and mean, or measures of spread, using their range and interquartile range. Well, I hope that this video helps. Make sure you message me on Schoology if you have any questions. Talk to y'all later. Bye.